Hello everyone. Today we are going to learn to model a parametric facade, a kinetic facade using parametric modeling and adaptive families. So we are going to perform this task in three parts. So the first part would be about creating the family, the basic family in a generic model adaptive family template. And second part would be about loading that generic model adaptive family onto a curtain panel pattern based family. And the third part would be about loading that curtain panel pattern based family into the base structure. That's our mass, like the structure that we had created last week. So this is going to be the overall structure of the task. So without further ado, let's get started then. Okay, so I would open the family template. Okay, so we'll go to new under families. Then we'll go to English Imperial because I'm working in Imperial. If you're working in metric, you can go select the metric folder. So under this folder, now we would browse, open the generic model adaptive template. Okay, so this is the basic template that you have to begin with. Okay, generic model adaptive. Okay, all your folders will have it, whether it's metric or imperial. So just select this generic model adaptive, and then we would get started with the basic model. Okay, click on open, give it a while. Okay, now once we have the screen, you can see this is the interface of the family template. Okay, so the next step would be to create 3 points of a triangle which would define the base of the base structure of the kinetic facade family. Okay, so we are going to create 3 vertices of the triangles, and thereafter we are going to model the further parts of it using the midpoints and the centroid and so on. So first we will begin with drawing the points, and so let's begin with that. Okay, so we'll go to an orthographic projection view, preferably the top view or the plan view. Okay, next would go to the create tab, use the point command, okay, point element from there, and place 3 points. Okay, so make sure you select the proper reference level from there using level 1. We are using level 1 now. So just go ahead and place 3 points in a particular order. So let's say we are going counterclockwise this time. Okay, so we are going to define the location of the vertices at particular distance now. So I fixed one of them at 2.5 feet from the center, and the other one also 2.5 feet from the center. So we will get the base of the triangle as 5 feet. 2.5 feet twice, 5 feet. Okay, and the height of the triangle would be √3/2 times base. Okay, so which would be around 4 feet 4 inches. Okay, so we've fixed the point locations. So now we will select the points and make them adaptive. So select the first point and select the adaptive command, okay, on modify tab. Next, select the second point, make it adaptive. Select the third point and make it adaptive. Okay, so this is the critical order. So you have chosen the counterclockwise order. So make sure we follow that while we place the family later on, while we load the family later on. Okay, So once we have fixed the triangle vertices, next step would be to create the sides of the triangle. Okay, so we would begin by selecting 2 points at a time. Okay, so we select point 1, point 2, and now keeping them both selected, choose the spline through points command, and as the line is selected, keep it selected and make sure you check the reference line option under properties. Okay, so repeat the same for point 2 and point 3. So once you have selected them both, choose the spline through points command, and while the line is selected, select the reference line. Repeat it for point 3 and point 1. Okay, ignore the warning for now, so just select the line and make it into a reference line. Okay, so once we have finished the sides of the triangle, next step would be to get the midpoints of the triangle. Okay, so let's go to a 3D view for now, and we would now go select the point element again. Okay, and then set the work plane. Make sure we set the horizontal plane. Okay, then select the point element and place it at the midpoint between the points 2 and 3. Okay, so Revit will prompt you to place it at midpoint. Okay, so taking help from that, you can go ahead and place the other 2 midpoints on the other 2 sides. Okay, so once you do that, okay, so now we will select the vertex and the opposite midpoint. Okay, and draw a spline through that. So use the spline through points command. Okay, repeat the same for the others. So point 1 and the opposite midpoint, and then spline through points. Then make it into a reference line. Similarly for the third one, point 3 and the opposite midpoint, spline through points, and make it into a reference line. Okay. Once we are done with the joining the midpoints, okay, next step would be to define a few properties. Okay, so before that, we would go ahead and place 1 point in the horizontal plane here. Okay, so let's first put the base. So take the dimension through point 2 and 3, add a parameter, select instance, and write base. Okay, let's call it base. Okay. After you define the parameter, make sure it's instance and reporting. Okay, we are going to use the same value, the base value, for deriving other parameters. Okay, so on this point, on this line between point 1 and the opposite midpoint, we will draw another point. Okay, so just place a point And once you have placed it successfully in the plane, just go to family types. Okay, now we will define a few properties. Okay, so first go to the new parameter option. We will create the parameter A. Okay, we'll make it instance property. Okay, and let these be length and dimensions. Okay, next we'll create another new parameter, call it H, make it instance parameter, and let that be also length and dimensions type. The third one now, so we'll create another parameter, call it PA. Okay, let that be also length and dimensions instance parameter. Okay, now we're going to define a couple of other new parameters. So let's call it H underscore NCP and say instance parameter and change that into number type. Okay, number type parameter. Say okay. Then let's create another new parameter. Call it PA underscore NCP. Make it an instance type parameter and also a number type. All right. Say okay. Now we're going to fill in the formula for the parameters we created. So for H, you can say A by 3. Okay. So that's 1/3 of the entire height of the triangle. Okay. Since centroid is located at 1/3 of the height. Okay. So we'll get A by 3. And we can enter the value for A. That will be square root of 3 by 2 multiplied by the base. Okay. Okay, so let's enter the value for A. Make sure you've entered the parentheses properly. Okay. Next. Let's enter the formula for H underscore NCP. That will be H by A. And for PA underscore NCP, that will be PA by A. Okay, we can apply that and say okay. Now you can go and select the point that we created last. Okay. And we will set up a few normalization parameters now. So just look at the properties carefully. So it's measuring from beginning. Okay, so you have the option to change it to end or keep it to beginning. Okay, so let's change it to end for now. Okay, and just above that, you will see there's a normalized curve parameter. So click on the gray box next to that. Okay. So you can choose the parameters from here. Okay. So now let's define it at h_ncp. Okay. So make sure that the point has show reference planes always, and uncheck the normal reference plane only option. Okay. Next, you can try deleting the formula and then you can go and enter it again. Okay, so now we have the point at the centroid. Okay. Now set work plane, choose the horizontal plane again, and place another point at exactly the same location. Okay, so select the point element and place it at the same location. Okay, it'll give you a warning. That's okay. Just click on OK and go ahead. Okay, so as you select the point now, just click on the blue axis. You can see the gimbal. So just pull it up using the gimbal along the blue axis. Okay, so now you have 2 points, just one below the other, one above the other. So for that point, you can change the offset value under properties. Okay, so select the gray box next to offset and choose the parameter A. Okay. Next, you can go and say, okay. As you change the parameter A, the point relocates itself. Okay. Which is fine. So now you can select the 2 points and draw a spline through these 2 points. So select spline through points. Okay, select that line and make it into a reference line. Okay. So once you have selected and into a reference line, just go ahead and place another point. Make sure you are drawing on face. Okay, on the vertical line, make sure you place the point. Okay. Select. Okay, now we will create a small line segment through the centroid and the midpoint of 2 and 3. Okay, so we will draw a small line segment there. So make sure you select the 2 points and select the spline through points and make it into a reference line. As you turn it into a reference line, you can see the small blue highlighted line segment, and that is the line segment you need right now. Okay, that's the one you will be working on. So once you can see that, we will go ahead and draw a point on that line now. Okay. So select the point element. Make sure draw on face is selected and just draw a line on the line segment. So make sure you are pressing tab on your keyboard to make sure that you are selecting only the small line segment and not the big, not the overall line segment. joining one. Okay, so make sure the small one is selected, and then only then you place the point. Okay, next you can go to family types. Okay, and draw and add a new parameter there. Let's call it HR. It's capital R. Make it also an instance parameter. Okay, and keep that as length type parameter. Okay, so we can call it. We can give the formula A by H. Sorry, A minus H. And next we'll enter the another parameter. Call it NCP. NCP for normalized curve parameter. Okay, so this is going to be our control point to change the family, to make the family adaptive. We will be changing this value. So define it, make it an instance property. Okay, instance parameter, and let that be a number parameter. Okay, go ahead, say okay. And now you can see it's by default set to 0. Basically, that value will be differing between 0 to 1. Okay, NCP will be differing, ranging between 0 to 1. Okay, so that's how your kinetic facade will open and close. Next, we'll add another new parameter. Call it HR underscore base. Okay, make it instance property. And yeah, that should be fine. Say okay. So now we are left with the formula for HR and PM. Okay. So now we'll enter the formula for HR. That's square root of HR square. Using the Pythagoras formula here. Okay. So select the point now. And as you can see, it is set to beginning. Okay. Now, if you change it to end and define a new normalized curve parameter for that, pick NCP for that, and then you will see that the point changes its location. Okay. So right now NCP is set to 0. If you change its value, the point will relocate. Okay. So you saw that the point moved. Okay. So the point is moving with the NCP value changing from 0 to 1. Okay, so this is going to be our critical point, the control point to alter the shape of the entire kinetic facade element. Okay, so make sure you give it a check. Make sure you change the values every time you add a few parameters, and make sure that it's going in the right direction. All the formulas are working and everything. Okay. So now we'll select the 2 points. Okay, and then we're going to draw a spline through that. Okay, so before that, we'll define the normalized curve parameter for that point. So make sure it's set to PA underscore NCP. Okay. You can check the values here. Okay. So we need to define the value for PA, the formula for PA. Okay. So for that, we need another parameter called LH. And another parameter, HR underscore NCP. Make it an instance parameter and number parameter. Okay. Next, we can copy the HR underscore base parameter from there, paste it here. Okay. So this will be HR base divided by HR. Okay. And remove the default from there and make sure you add HR. Okay. You have to be careful about the values you add and the parameters you add, because any inconsistencies in unit will not let you go forward. Okay. So next LH, we will define the formula for LH. That will be H multiplied by 1 minus NCP. Okay. Within parentheses, 1 minus NCP. Okay. Next, we are going to insert the value of LH here to arrive at the formula of PA. That will be square root of H square minus LH square. Okay. That will be the formula for PA. Okay, so make it H square minus LH square, square root of that. Okay. Make sure you are matching these values, these formulas, whenever you are modeling. Okay, these are very critical formulas. If you are not getting it right, there might be some issues in the process of modeling the family. Okay. So next step, we will draw another point on a line segment between point 2 and the centroid. Okay. So make sure you select centroid and point 2. Draw a spline through points. And make sure you change the line into a reference line. Okay. And then we'll go select point element. Press tab on your keyboard to select the smaller line segment and only then place the point. Okay. So now you can select the point and define the normalize curve parameter for that. Okay. So make sure you pick HR underscore NCP for this point. Okay. Then we can define the NCP value and check if it's changing. Okay. So we can change the values of NCP, and if it is adapting properly, that means the formula is working. Okay. Make sure the normalized curve parameters are set up properly for all the points. Okay. And only then we will go ahead with drawing the next set of reference lines and the panel thereafter. Okay. So now draw a spline through points through the vertical and the point opposite to the point number 1. Okay. Now point number 2 and the last selected point. Okay, draw a spline through these 2 points. Okay. And now join this point and the vertical point on the vertical. Spline through points. Okay. And make sure you turn this also into a reference. So make sure all these points are connected through reference lines. Okay. Next, select all the 3 reference lines together. Go to create form, pick the solid form. Okay. So once you pick the solid form, you'll have 2 options, either the one with the surface or other one is the paper thin surface. So go the one with thickness, the first option with the thickness. Okay. Now we'll go and change the value for thickness. Okay. It can be adjusted. So go to properties. Okay. Positive offset. We can add a new parameter there. So click on new parameter and call it thickness. Okay. Now make sure you make it into an instance parameter and say okay. All right. Now you can go to family types and set the value for thickness parameter. Let's keep it at 1/4 inch. Okay. Okay. So this is the base part of the first part. Okay. You can replicate this all over to create the panel hereafter. Okay.
So before we move forward, we have to make sure that a few normalization parameters are covered. For that, we'll check the normalization parameters in the vertices again. So make sure this is set to beginning and create by MCP next to parameter there. Make sure this edge is set to beginning and set to MCP here. Basically, this value 0.1 should be uh, the value which is close to the beginning point. Okay, so here have the beginning here and the end here. So whatever is closer to this edge, this point will be close to 0. And whatever is closer to the centroid or the faraway point will be close to 1. So this is the exact same logic that we are going to follow everywhere. Okay, so we're going to repeat the same process. And this is what we have to do. Also for this edge, uh, the one joining point and the two on the centroid, make sure this point lying in between is set to N, which is okay. So then you can make sure this is set to HR underscore NCP. And under family types, we can go ahead and set again HR base divided by HR. This is how your panel will be looking, part of that will be. So you should be able to flex this and check that the curtain panel is adapting accordingly. So as you change the NCP value, the control point value, which is the only editable parameter here. So as this value changes, you should be able to see how the part of the panel opens and closes. Okay, that is 0.5. Okay, then it partially opens. And if you reduce it, bring it closer to 0, then it fully closes. Okay, so the panel is covered when it's closer to 0, and the panel opens, revealing the data as the value gets closer to 1. Okay, so this is the same intent that we're going to follow all throughout and repeat every. So let's continue. So we have the point number 2 is done. So next we're going to create small segment here between this point and this point. We will continue with creating the same pattern. So next list. This point and this point. Let's go for spline through points. And make sure when the line is selected, you turn it into a reference line. Okay. So now this is turned into a reference line. Make sure that you go ahead and place a point here. Press tab on your keyboard to make sure that the smaller line segment is selected. Next, you can select this point and the vertical point with vertical axis. Select line through points and make sure that this is also turned into a reference line. Okay. Next, select the point and select the last vertex here, last vertex of the curtain panel, and make sure you put it into spline. Okay, you get a spline and turn it into a reference line. Okay. Next step, we would be changing this value. We will be normalizing this parameter. Okay. So for that, uh, make sure that this point is selected. This point is selected first. Then you make sure this is at the beginning. Parameter is NCP. Okay. Now if you turn this to NCP, so the point kind of changes. go to the elevation, check the way the system behaves. Okay. I will change the value from 0.9 to 0.5. So this system behaves similar. Okay. So this part and this part behaves similar. So this means our formula is correct and it's working properly. So we'll go ahead. Now I will select these three reference lines together. Okay. Once we created this one, create form, select solid form. First option, the thickness. Okay. And here under the positive offset, you can set the parameter that we had created earlier. Alright. So next step, we will go ahead and generate another small spline here and place another point here. Okay, so for that, make sure you select this point and we can draw it. Select spline through points. And as it is selected, make sure you turn it into a reference line. As this is turned into reference line, now next let's place another point here. Press tab, press tab. Make sure that the smaller line is selected. Okay. Keyboard, make sure the small line is selected and go ahead and place this point. Next step, we will be doing the same process. We'll connect it with the two other points, the vertical and the last vertex. And then we would normalize it. And so here, select this point. So parameter would be char underscore entity. We'll just repeat this process again. So let's start. Keyboard. Select this and make it into our NCP. And make sure this is set to 10. Make sure it's there. Next step, we would find this point and this point. You can just find the point. Let's turn into a reference. Next step, we will do the same thing between this point. So, so select the point and this is turned into a reference line. Now we will select the three reference lines together. This one and this one. Sure, you turn it into a solid font. So create font. And make sure choose the thickness parameter from here to the same value. Next, we'll continue with the same process on this edge. So we'll draw another small spine three points. So select these 2 points, spine 3 points. Make sure the line is turned into reference line. So when that is highlighted, next you can go ahead and place the points there. So when you place the point, make sure the small reference line is selected. So press tab on the keyboard when the small reference line is selected. You can go ahead and place the point. So next, for this point between 1 and 3, make sure the normalized curve parameter is set to NCP. Okay. And this is the beginning. Okay. Select this point and turn to this line. Okay. This line. Vertical. It also turn into a reference line. Now we select these two reference lines together. This line, reference line, three reference lines, then create one. With the first option, with the thickness, and go select the parameter from there, of thickness, and there you go. At this point, you want to go and check okay, whether the panels have turned out properly. So you can go and check this NCP control point parameter. And you will see that there is a problem. Show you this. Yeah, now it's behaving properly. So now you can go ahead. Alright. So next, we will set the same points here at this edge, join them with these two sides. Form. Okay. So let's go point on the three right there. Select line 2 points. The right point, then we'll select the line 2 point option. So turn it into a reference line. I will place the final point here. So for that, correct. So before we do that, highlight it and press keyboard. Next, select this point. And select this earlier point. Line 2 points again. Into a reference line. Select the new point. Find the vertical point. Make sure you select these two and draw a spline here and make that spline into a reference line. Okay. So have a better look. You can see this is reference line. Okay. So we will select point, sorry, these two lines and this reference line together, three of them, and make sure you select the create a solid form. Again, go for the one with the thickness. Dot sign this thickness parameter. Okay. So just to check, we can go to the top view, and now we are left with the last panel. Okay. Last step so that we can finish the panel. So we already have the points here. We will just select this point, select this point, make sure we put line there, and make sure we turn it to the reference line. So after you have drawn the reference line, make sure you select the three reference lines here, these edges, okay, and create a form. Start form. Okay. Next step, we'll go and assign the thickness parameter. Okay. We are done now. So we have created the panel, and you can check to fix the values. So you can see the curtain panel opens up as we change the value to 0.9, and as you change it back to 0.2 or value close to 0, the panel increases. Okay. So, yeah, that's the first part. We have finished the first part. Basically, we have created the generic model, adaptive type of generic model, and now we will be loading this on a curtain panel pattern based family. Okay, so for that, we will first save this. Okay, we will save this at a location. So, save this. So let's call it generic model. Okay. Save this. Next step will be part 2. So we will go create a new family again. Okay. So new family. And now we will open a family template, which is curtain panel pattern based. Okay. We'll go to English. We will browse, open the working materials. So I'll go to curtain panel details. We will go open this one. All right. Next, we'll select this tile grid here. Okay. Make sure I turn it into triangle flat, because this is going to be the final grid style in my triangle structure, tree structure. Okay, so once I have this triangle flat pattern here, I'll go select this, change the horizontal spacing. So since the base was 5, so I'll just divide that by 2 and enter the value here. So 2.5 feet horizontal and vertical will be uh, 3 by 2 times the base, which is 4 feet 4 inches. Yeah, I have my uh, family basic curtain panel family here. So let me go back to my Henrik model family. Okay, uh, Henrik model adapter. So before I add that to this family, okay, I'll just go select and apply a material to these. So select, paper out the generic model. Okay. In the material, we just select the material for this. Let's go and fetch all of the material. So let's do something like this. Take realistic mode. Change this appearance to see this color has changed now. Okay. So now remember we had created the 2 points 1, 2, and 3 in the order. So we will be basically changing these values, placing these values uh, in this. So we will be following the same order. Okay, so let's go to this and let's load this into the project. So 1, 2, and 3. So I will have to place the 1 on 1, then 2 on 2, and 3 on 3. So 1, 2, 3. So you can place an adaptive family. Okay. So once you change the values, it would be able to uh, adapt it in any uh, method, in any distance, in any dimensions thereafter. That is the purpose of using an adapter family. So basically, after placing point 1, 2, and 3, uh, you know that these curtain panels are located properly now. Next, we will apply this curtain panel on the base structure. Okay, so the cylindrical tower structure we have drawn, we will take it to that and we'll apply it to that. So now let's look at the curtain family, curtain wall family, and how we can load that onto the base structure. So to begin with, we need to make some modifications to the base structure. So I'm going to illustrate to you with the help of a very simple example. Okay. So I'm going to create a simple mass, but you will be required to apply the same principles on your base structure. Okay, on the tower which you have created. So go to mass, massing inside, and start creating a mass. I will start creating surface. Okay. And all right. So you can see we have a surface here. Okay. You cannot see the visible surface. You please change it to shaded or consistent. Then we select the surface and select the divide surface. So basically, if you have a mass, if you have a curved mass or straight mass, any sort of mass, then you can select the surface and divide it. Use it for divide surface. Now, next, since we have generated it on a triangle flat pattern, so we'll select this surface and change this to triangle flat pattern from here. So now you can see that it has changed into a triangle flat pattern. Next step would be to generate the V grid and the V grid, basically the horizontal and vertical spacing. Okay, so for that, we select this, change this V grid and V grid distance. And here at the distance value, just next to that, click on this associate family parameter and you'll add a couple of parameters. So we'll go to the new parameter option. We add V grid here. For this V grid also, distance, we'll set up parameter. Next, you can see that these are controlled by parameters. As you select the surface, so you can see this is controlled by parameter. Basically, we have to make these as functions of the base of the triangle. For that, we'll get family types. Okay. Here we will add another new parameter called base. And we will make the U grid and V grid as functions of the space. So for that, we will add V grid base by 2. U grid will be square root of 2 by 3, the whole thing multiplied by base. We can assign this value 5 feet for our structure. Okay. See the size is updated. Okay. Next, we have this kinetic facade family. Okay. So you can change the NCP value and as you select it here, you can change the NCP value here. Okay. This is basically after we have loaded it onto the base, like curtain wall family. This was the first family we created, its generic model adapter, and then we loaded on the curtain wall family, curtain wall family. So from here, as you select this, you have the liberty to change this value. So at this stage, what we will do is we will change this to 0.9. Okay. We can save it as an open and close family. Okay. So go to file and save as kinetic open family and reduce the value and then save it as kinetic close family. Okay. So like that, you can have two families, one with a completely closed pattern, maybe with 0.1, then another one, you just modify it slightly 0.3 with certain degree of, open areas, and then you can modify it with different values and save that, different so it like different families. Once you have done that, you will load that onto this base structure, as in your base tower structure, the one with the mass. Okay. To do that, you will see that I'll load it here first. You load it here, you will see that the family has shown up. Okay. So once you replace this, okay, like that, you will be able to see, okay, that there is kinetic facade family applied also. So you can also try this with the help of the kinetic generic model adapter family. Load that, okay, try loading that, and even with that, you can, change some values. Okay, so for now, I can just select it individually, select uh, individually and delete them. Okay, select them and delete them individually from here. Okay, like that. So if I want, I can load this one also to my destination mass project. Okay. Then I will go to create component. Just take the kinetic generate model adaptive family from there. And then I would go ahead and place it. Okay. Just in the same order like I drew the kinetic. Just define the values 1, 2, 3. Once you have done that, you can see that this family gives you the liberty to change the values. Okay. So if you want to change it to 0.9, it will change the shading device. Okay. If you want to change it to 0.1, it will completely close it down. Okay. So you can use both the generic model adapter family and you can use the particular family which hosts this family and you can change the entire pattern. Like you can selectively change them into these, or you can delete, or you can keep whichever ones you want. Customize the pattern, and then you can finish your mask once you have done. So behind this, the layer, okay, behind this mask would be your glass curtain wall layer. Okay. So once you apply this all over, you will have a mask which somewhat looks like this. Okay. And for after you have applied it all over, right, you can selectively, make some of them, completely closed. You can keep them open at different angles just by using the NCP value, changing the NCP value as I discussed. Okay. And then you can take a nice camera perspective and maybe you can also take a render. Okay. Just take a good render for that. Okay. Maybe add a background or you are free to use any render engine for that matter. If you want Revit or you can use Lumion, and please take a good quality render, add some context to that. Okay. Make it interesting and share your outputs with us. Okay. So that's all from my side. Good luck with the task. So for the task, you have to basically create the same kinetic facade family like I illustrated. Okay. First created in the generic model adaptive template and load it onto the curtain wall template and then finally load it onto your base structure the way I discussed. Okay. So do keep in mind the technicalities and good luck with your task.